Hi everyone. In this video I'm going to show you how to do the operation of matrix multiplication. And just multiplication because it is a very unique part of matrices. And that multiplication does not work the same way addition and subtraction works. It does not work in standard multiplication. It works in a very different format. The most comparable thing is actually pretty much the dot product. When we've done dot product recently with the vectors, that's how we can actually think of matrix multiplication, but just on a larger scale. So the idea is that matrix multiplication can only work when dimensions line up a very specific way. So previously, if dimensions were exactly the same, that's when you could add or subtract them. That is not the case with multiplications. If I do a 2 by 3 times a 2 by 3, actually multiplication will not work. But a 2 by 3 times a 3 by 1 does work. So what gives? What we need is what we call the inner product. The two inner numbers need to match. And what's going to end up happening is the outer product, the two outer numbers, is going to be the new matrix. So here are the four matrices we've used before. So how we could add A and B is no longer the case. I cannot add, or I cannot multiply this A matrix and this B matrix. I can multiply A and C, but not A and B. But it doesn't mean the same matrices can't be multiplied. C times D could work because C is a 2 by 2, D is a 2 by 2. So when I line them up, 2 by 2 times 2 by 2 will work. What makes this really interesting is that if two matrices can be multiplied in both directions, so let's say A times B could be multiplied this way, they may actually not work this way. So for an example of this, here's a different set of matrices. Matrix A is 2 by 4, and matrix B is 4 by 3. So if I do A times B, I get 2 by 4 times 4 by 3. And since the inner products match, that will work. But if I flip the order, B times A, I have a 4 by 3 times a 2 by 4. Well, the inner products do not match, so that cannot work. So matrices actually have a really diverse way of being multiplied because sometimes the order does matter, sometimes the order does not matter, aka if and only if they are square matrices, and sometimes the order doesn't matter at all. A and B can't be multiplied no matter how I try to arrange them. So there's a really interesting sort of array of possible options to get just with the ability to multiply, let alone the results. So let's look and see which ones we can multiply. Now again, A is 2 by 3, B is 2 by 3, C is 2 by 2, and D is 2 by 2. So again, let's keep order in mind. So we know right off the bat, C times D can work, and so can D times C. Both of these will work. So let's look at our next possible options, A times B and B times A. So I had just talked about this. If I try to line them up, the inner products will never match, so they do not work. Now here's where it gets more interesting. A times C, so A is 2 by 3 times a 2 by 2. So the inner products do not match, but C times A, 2 by 2 times 2 by 3, will in fact work. In the same case with D, D times A will not work. Oh, sorry, D times A will work, whereas A times D will not work. And we can replace A and B in the same case. So of all of these matrices, there's only 4 that we can multiply, or 6 that we want to multiply if we can. C times D in any order, C times A, D times A specifically, or C or D times B in that specific order. So that's how we can multiply, determine what we can multiply. Let's actually see how we do it. So let's do this operation. So I'm going to write it out. I'm going to use a lot of different colors here because the first time you see this, it may be very helpful to see it with a lot of colors. So here's the C matrix times the A matrix, 4, 2, negative 1, 6, 7, 3. So the way that this works, like I said, it's very similar to a dot product. I'm going to take the first row of matrix, the first matrix. See how there's two elements in that, 0 and 18? Well, in matrix A, the only way to get two elements is column. So row times column is actually what we're going to do here. Row times column. And what we're going to do, just like the dot product, is we're going to multiply piece by piece. So let me show you. So 0 is the first term, 4 is the first term. So I'm going to go 0 times 4, and then I'm going to add the next part. 18 times 6. Let me make sure I have the right number here. So I'm going to do this operation. 0 times 4 is 0, plus 108. That is going to be the first entry into my new matrix. Okay, so I did row times column. So let's try that next one. So I'm going to take the first row. I've already multiplied it into the first column, so now I'm going to set my target to the next column. So again, piece by piece, 0 times 2 plus 18 times 7, which would be 126. 0 times 2 is 0 plus 126. So my next entry is 126. All right, so let's do it one more time. First row, I've used column 1, I've used column 2, now I'm on to column 3. So 0 times negative 1 is 0, 18 times 3 is 54, 0 plus 54 is 54. So we've now completed the first row multiplication. So first row times first column, first row times second column, first row times third column. Notice how it gave me first row, first column, first row, second column, first row, third column entries. Okay, so now we're going to repeat this process one more time. But now I've exhausted the first row into all the columns. So now we're going to do this second row into all these columns now. So 9 times 4 plus negative 5 times 6. So right here, this is 36 minus 30, which gets me 6. Okay, moving on to our next one. 9 times negative 5 times these two values here. So we get 9 times 2 plus negative 5 times 7. So that's 18 minus 35, that's negative 17. There it is. And then our last one here, I don't know if I've used this dark blue yet. 9 and negative 5, negative 1 and 3. So again, cell by cell, 9 times negative 1 plus negative 5 times 3. So negative 9 minus 15 is negative 24. And so again, we want to think about second row times first column got me second row, first column. Second row times second column got me second row, second column. Second row times third column got me second row, third column. The thing about matrix multiplication is each row times column gets me one individual value. That's what most people get stumped about. It's actually me taking the entire thing and condensing it into one number, okay? Now again, we talked about the inner product matching. So this was a 2 by 2 times a 2 by 3. So you can see that the inner products do in fact match. And as I told you, the outer products will be the new dimension. And do you see that's what we got here? Another 2 by 3. So there's a way to kind of make these multiplications work, but that's how we do it. Okay, so why don't we try 2 more? I'll go a little bit faster. So C times D, hopefully there's more zeros involved. Just the one. Yeah, that's okay. So I'm going to do C times D. I'm going to do it again with some colors. 0 and 18 times here. So I get 0 times negative 4, which is 0, 18 times negative 2, which is negative 36. All right, so let's do first row, second column now. 0 times 9 is 0, 18 times 3 is 54. Okay, I've now used up the entire first row, so now we move to the second row. So now we have 9 times negative 4 is negative 36, negative 5 times negative 2 is plus 10. And finally, our last row, let's go with, I don't like the orange all that much. Let's go with the pink. Oh, wrong thing. 9 times negative 5, 9 times 36. So that gets me negative, oh no, it's positive 81 minus 15. So I get negative 36, positive 54, negative 26, and then this would be 66, I think. So that's C times D. Now what gets really interesting is I have D times C here. So if I flip the order of the multiplication, you will see something that hopefully isn't too jarring, but if I do this, so again, negative 4 times 0, 9 times 9, negative 4, 9 times 18, and negative 5. Can't read my handwriting there. So negative 4 would be negative 72 minus 45. We've used up the entire first row, so now we're going to move to the second row. Negative 2, 3 times 0, 9, so that's going to be 0 plus 27. Negative 2, 3 times 8, negative 5 would get me negative 36 and negative 15. Okay. So I get 81, negative 1, 17, 27, negative 61. Now again, you may be looking at these and may be saying, I don't see anything, and that's actually the exact purpose. In standard multiplication, 2 times 3 is the same as 3 times 2. In matrix multiplication, they are not always equal. So getting them to be different numbers is not bad. It's actually probably correct. There are some specific situations in which they are exactly the same, but until you know a lot more about how matrices really work, it's really hard to tell. So you have to do the multiplications out in order to determine what their values will be. So none of these end up being the same at all. Sometimes some of them are the same, but it's not something that you would expect. And so, for example, the last thing here, similar to dot product, similar to distribution, I could make this A times C plus A times D if I was to distribute this. But that's really a lot of work. So if I want to kind of do this a little bit quicker, I can just do C plus D. So negative 4, 27. This is me just adding C and D together. 7, negative 2. And now that I found C times D, I can actually just do this multiplication here. Okay. Now, this might be a good time for you to try it yourself. That way you can see if you've done this correctly in the middle of the video. But again, looking at this, there's a problem. This matrix operation cannot be done. And the reason, even though I could do the addition, this is a 2 by 3, and this is a 2 by 2, meaning it cannot be multiplied because the inner products do not match. If this had been flipped around, negative 4, 27, 7, negative 2, times the matrix 4, 2, negative 1, 6, 7, 3, then it could be multiplied. So here's what I want you to do. Why don't you try to do this multiplication really quick, okay? And then pause my video now so that way you can try it on your own, and then when you unpause it, I should have my answer up. So pause it now. All right, so this should have been the matrix that you got. 141, 181, 85, 16, 0, negative 13. Okay, I know this is kind of a tricky concept the first time you're doing it. I promise you it does get a lot easier. You just have to practice the row times column and kind of get over the fact that it's not a standard multiply two numbers and then being done. It's just basically a two-step multiplication. I know it sounds kind of annoying, but that's just the way that this works. So I hope that was helpful in this. In our next video, we'll talk about how matrix multiplication might be useful, as well as why we don't have matrix division. That doesn't quite exist in the way that you think it does. So that will be our next video in this unit. See you then.